Hello everyone, myself Ruth Pratap Singh and my teammates are Naman Gupta and Rohit Singh. For our final year project, we have worked on performance evaluation of multi-channel underwater optical wireless communication system with OFDM modulation technique. So if we see multi-channel, that's a very good word that we have used and our novelty in this case. Multi-channel basically means having two medium values using in one go. In our case, the transmitting signal will undergo two different losses based on the particular medium property. So in our case, we have used two different medium, which is river water and sea water. So our transmitting signal will undergo both of these properties. Like for few distances, will go undergo river water properties, and for another half, it will go to sea water uh, properties. So now I will directly take you the Opti system software window. Like we have used Opti systems for the simulation. So here we go with the Opti systems, and yeah. So this is the basic layout for our CISO configuration. So now I'll start with the CISO. So the system employs a pseudo random bit sequence generator and a 4 DPSK sequence generator to process the input data with a length of 2 to the power 15 minus 1 with a 10 Gbps bitrate. An OFDM modulator with subcarrier of 2048 and FFT points is used to combine the two parallel sequence into one OFDM signal. These OFDM signals are then passed through low pass rectangular filter, and after that we have got an electrical gain of 1 dB. And once the gain is added, the laser, we have used CW laser, and the laser integrates with the input data we have got, and dual port MZ modulator is used for that. Once we have got the modulated data, it directly goes to a coupler, and the coupler gets the combination of both the data, and the data then is transmitted to MATLAB component. So in this case, the MATLAB component basically consists of Alamoti coding and underwater channel properties. So Alamoti coding is used to enhance the signal which is received after deteriorating from the underwater channel properties. So in this case, the signal will go through the underwater properties like river water and ocean water properties, and the signal will get deteriorated. And to enhance the signal quality, we have used the Alamoti coding. And the enhanced signal goes to goes to the output unit of our communication system, which can be called as a receiver unit, which consists of couplers, four couplers, which basically combines all the data, and photodiodes. So photodiodes basically converts electrical data, optical data to electrical data. So once when we have got the electrical data, we have used electrical subtractor and then transimpedance amplifier, and and we have finally used OFDM demodulation technique. The OFDM receives the eliminated guard intervals and use the FFT stage to restore the transmitted signal. The 4 PDSP sequence decoder converts the two input from M array into binary output, and the BER test unit is used to determine the BER of the system. And to get the value of power, we have used optical power meter. This basically shows the optical power that we have got after each component. And once we have got the BER of the value, then the same signal again goes to the DPSK and the chain goes on.
Like CISO, we have made a simulation for a 2x2 MIMO configuration. It is employed to mitigate the effects of various challenges that are specific to multi-channel underwater environment, such as attenuation, scattering, and optical turbulence, which can degrade the quality of the optical link. The technique utilizes two transmitters and two receivers to simultaneously transmit and receive optical signals underwater, providing improvement to the capacity, reliability, and performance of the communication link. Unlike the CISO schematic, here the transmitter sends the data directly to a fork which splits the signal in two. The resulting signals are then transmitted to a different MATLAB component, including the underwater channel with the Alimony coding technique. Here, the underwater channel consists of all the losses which happened in the real-time system, and to enhance the same deteriorated signal, the technique is used. The output signal is then sent to the receiver component, and thereby it follows the same steps as a CISO schematic.
as what we have already observed in CISO and 2 cross 3 MIMO configuration as per. So as we can see that this is the proposed multi-channel DPSK OFDM system with 4 cross 4 MIMO configuration, which is a system that has 4 inputs and 4 outputs. The transmitter then sends the data directly to a fork, which splits the signal into 4. Thus, the resulting signal are then passed through a MATLAB component, which consists of underwater channel with the LMOT coding. As once the signal passed through the MATLAB component, it goes to the power combiner. Then the output of the power combiner is one signal, which is transmitted to the receiver component, and it follows the same step as of the CISO.
So now I will show you a simulation of one of our configuration that we have gone through, and we will try to show you all what kind of results we can get from our schematic. So I will, for you guys, like I will run the layout one, which with CISO configuration. So if you see, like this is the laser component that we have used, and when we click on the properties, we have used 450 nanometer laser with a power of 20 dBm. So what basically it means that the power input that is going in the component is 20 dB. And so once it goes to the modulation technique and the channel, the power will go down as the signal is getting deteriorating. So in this case, we will just see the power, and similarly, we can also get all other values as per our need. So to run this schematic, we just have to click on this play button, which is calculate and run. So now it's running. It takes a few seconds to run and compile. So once it will compile, I'll talk about the power that we have got. And it also opened the MATLAB channel, if you can see. So this basically says that your MATLAB code has successfully run. Uh, so now it's saying that your calculation has been finished. So now when we click on the optical power meter, which is very close to CW laser, basically means it is connected directly to the CW laser. So when we click, it says we have 100 milliwatt of power with 20 dBm. And now once the signal has gone to the modulator where we have added the input signal and the electrical gain and everything, and once it has passed through the X coupler, the power should deteriorate because it has passed to optical, passed through the modulator and input data and everything. So now if you see with the power, it has gone down to 15 milliwatt. Out of 100, we have received only 50. And once we have got the 15 milliwatt power, which is the output of X coupler, then the input signal is directly going to the MATLAB channel. So if you see MATLAB channel, the signal will be going through a lot of kind of losses, for example, scattering loss, phase shift, absorption loss, and many other. So the power will deteriorate even more. But we have used enhancing technique, which is allomoty coding. So the output will be much better compared to without the allomoty coding. So now when we click on the optical power meter, it is showing 107.69 in e to the power minus 6, which is basically minus 9.678 dBm. This is comparatively very better. Like if we don't go with allomoty coding, this would have gone in like minus 25 dB. Like the paper that is already published, and if you go through that, the power output without allomoty coding will be approx 25 dBm. And in this, we have only used 5 meter in total distance. 5 meter, basically the signal will be traveling 2.5 in river water and another 2.5 in ocean water, and the signal deteriorates and everything will happen, and the allomoty coding is used to enhance the signal. And so the total power that we are getting is 107.699 into the power minus 6. That is comparatively very good. And similarly, if someone wants to have more other values, they can use different components. If they want to generate any kind of graphs, then they can use graph plots that are there in OptiSystem. So that is there from our side. And similarly, you can find all other values. So yeah, thank you so much.